Okay, on to nested data. Nested data turn out to be a huge problem, and regression isn't always the best tool for it, but linear models are reasonable. But what I want to do is I just want to demonstrate exactly what nested data are and some of the problems inherent in them. So what it comes down to is nested data are problematic because observations that you make are dependent upon other observations that you make. So for example, suppose that we have a school and you randomly assign kids to one educational program or another, and you assign them by classroom. Well, it could be that the classroom that you get assigned to early on in the semester or the year makes you different. Smart kids get assigned classrooms with other smart kids or whatever. And so therefore what you could have is the potential for an effect that's due to the classroom and not to the treatment itself. And so when we're analyzing nested effects, they're really complicated, and we need to understand what the content is. But what I'm going to do is, of course, I'm dealing only with manufactured data, and I'm going to manufacture my own nesting problem. And what I'm going to do is I'm going to use some predictor, and I'm going to use n1 as my new variable for nested one. And then I'm going to use c1, which is to generate my nested variable. And now my nested variable is a continuous variable, and all I'm doing is I'm shifting the mean between, remember c1 is my categorical variable, and it has 0 or 1. It's everybody below the mean and everybody above the mean, right, separated for x1. Now my n1, my nested variable, the group 0, or for my categorical variable 1 for group 0, they're going to have a mean of 0 and a standard deviation of 1, and there are 50 of them, or I suspect. And then because it's the median, and then for the other group where categorical variable 1 is equal to 1, they're just going to have a mean of 0.5. So I'm going to shift them up a little bit. So they're going to have a mean of 0.5 but a standard deviation of 1. And what happens when I correlate them? They're correlated about 0.16. These are now C1 and N1 are correlated. So we already know what happens when you have correlated predictors. What happens is you have an attenuation due to multicollinearity, attenuation in our hypothesis testing. So what I want to do is just show you exactly what happens when I'm going to test this. I'm going to submit all of this at the same time. And what we see here is C1 is my categorical predictor, and it's a significant predictor, just as it was before. And N1 is a significant predictor. But what's going to happen is my C1 and N1 are confounded a bit, and I can show you this by just running VIF. And look at this. Not a lot of collinearity in VIF, but they still are correlated. They're correlated enough, and I created a mean difference in them, and that mean difference may actually influence the outcome. Now, there are whole lots of ways in which nested data can actually occur that I didn't take into consideration the dependent variable, but typically what I recommend people do is plot the effects so that at least you can see if you have a categorical variable and there's some nesting, you're likely to see some differences either on the dependent variable or on the predictor, and most importantly that nesting is likely to influence what the effect is across the two groups for a variety of predictors on the dependent variable. So nesting is both a theoretical, it's theoretically relevant, but it's also empirically relevant, or not just observationally, but it is quantitatively important because nesting affects the interpretation of the data. So we have 2 more videos, so stay tuned for them, and we'll wrap up week 2.